Now they turn their attention to the front of house area. They set up two effect racks, a monitor EQ rack, and the console. For today's event, the front of house position is in a prime location, 40 feet in front of the stage and dead center. Let's take a closer look at all the front of house gear, starting with the drive racks. Without a doubt, the gear in the drive racks are at the heart of the sound system. They contain all the system processing gear. This top rack contains the dynamic processing gear and effect units. On the left are the compressors and noise gates, and on the right is an assortment of digital reverbs and delays. The lower rack houses the system processing gear. At the top is the digital house EQ. This is the system compressor and crossovers. On the right is a CD player and cassette deck. Now that we've seen the fronts of the racks, let's examine the backs and see how things are wired. Here's the top rack. Notice that the left side of the rack contains the power distribution for the devices, and the right side contains the connector panel with the inputs and outputs of the devices. Keeping the racks consistent this way allows cabling to be run efficiently. These two multi-pin input connectors are for snakes that connect the rack with the console. This first 16-channel snake breaks out to 16 tip ring sleeve connectors which patch 8 compressors into the console. The second 16-channel snake patches 8 noise gates into the console. Below these two breakout panels is the effects connector panel. This is where the ins and outs of the digital reverbs and delays in the rack show up. These are patched to the console using simple harnesses. On the back of the lower rack, like the upper rack, the power distribution for the devices is located to the left side, and the connector panel is on the right. As we saw on the front, this rack contains the system processing gear, including the system EQs, compressors, and crossovers. These units are used to process the output signal of the console, whereas the dynamic compressors and noise gates are used to process the inputs coming into the console from the stage. Signal from the stereo output of the console is fed into the EQs, out of the EQs into the compressors, out of the compressors into the crossovers where it's divided into sub, low, mid, and high frequency outputs, and fed down the 16-channel return snake to the amps at the stage. That's the 16-channel return snake connected on the lower right-hand side. At the console, the engineer patches the output harnessing for the compressors and noise gates. This is the console end of the 52-channel signal snake, which is permanently patched to the console. When the 52-channel snake is fed from the stage, it's simply connected directly to this multi-pin connector, and the input wiring from the master panel to the console is complete. Once connections have been made between the effect racks and console, the engineer lays masking tape along the front of the mixer, under the aux sends, and under the submasters. Labeling the various inputs, outputs, effect sends, and aux sends will help him keep the mix organized. 3 bands are performing today, each with different instruments, and all 3 playing rotating sets throughout the afternoon. Marking everything is the only way to keep it all straight. The console being used today is a Yamaha PM3500 40-input split console. It's called a split console because the master control area here splits the console into 2 parts, one section of 24 inputs to the left and a smaller section of 16 inputs to the right. One benefit of the split console design is that from a more center position, the engineer can reach all the channels. A closer look at the master control section reveals more of the console's features. 4 stereo line inputs, 8 voltage controlled amp faders, 8 aux sends, 8 submasters, and 8 matrix outputs, 4 of which are stereo. The matrix section is a powerful feature of the console. It's made up of 8 rows of 10 input knobs and 1 output knob. Each input corresponds to one of the submaster buses or left and right bus. So the 10x8 matrix design refers to its ability to have 8 separate and distinct mixes of the 10 submasters. For example, matrix 1, which is the first vertical row of 10 input knobs, represents the output of submaster buses 1 through 8 and the left and right bus. Matrix 1 can have less or more of any of these 10 buses. Matrix 2, the second row of 10 input knobs, can have any amount of the 10 submaster buses it wants, and so forth on down the matrix. During complex sound reinforcement setups, signal may be needed for a variety of other feeds, such as a recording setup, or a video feed, or delay speakers, or fill speakers, to name a few. This makes the console extremely flexible in routing signal beyond the typical left and right main outputs. Below the matrix are the console's 8 auxiliary sends. For today's setup, the first 4 sends are being used for separate monitor mixes for the band, left, center, right, and next to the drummer. The next 3 aux sends, 5 through 7, will send signal to the effects units. The engineer has patched in 2 digital reverbs, a Lexicon PCM80 for vocal reverb, and a Yamaha SBX 990 for a drum reverb, as well as a Roland SDE 3000 digital delay. The 8th aux send will be used to send instrument signal from the kick drum, floor tom, bass, and keyboards to the subwoofer crossover. Using an aux send to send certain instruments to the subwoofer crossover is an excellent way to add more low end to certain instruments without muddying up the overall mix. With a CD connected to one of the stereo line inputs on the console, the engineer now checks the system signal chain. This is done to ensure that output from the console is correctly passing through the house EQs, through the compressors, and into the crossovers. The crossovers are set to the manufacturer's suggested settings for the speakers and horns being used in the main speaker cabinets. In this case, roughly 80 Hz and below for the subs, 250 Hz for the mids, and 3 kHz and above for the horns. To protect the main speakers while the signal chain is checked, they're muted with a muting switch on the crossover. After the engineer confirms signal chain on the left and right side, he turns the mains up and runs pink noise generated from the console's pink tone generator through the system to make sure the speakers are connected properly. To protect the speakers, the process is always done the same way. Highs first, then mids, then lows, and then the subwoofer. If the speakers were connected incorrectly, it would be much less damaging to have high-end signal to the low-end speakers than low-end signal sent to the high-end horns. After confirming the speakers are connected correctly, the engineer plays a familiar music track through the system and listens carefully to see where he may need to tweak the mains. Using a stereo 6-filter digital parametric house EQ, he finds several frequencies where the signal needs to be cut. The digital parametric gives the engineer a visual reading of the cut or boost of any frequency. The dip can be widened or narrowed to a notch filter, and frequencies can be swept easily using a rotary dial. The display is showing the current house EQ curve with the input signal of the music track at various frequencies showing on top of it. Once the system is tweaked, the engineer moves on to set up and check the monitor system. Each channel on the mixer can send its signal to any of the 4 auxiliary monitor sends. Since each monitor has its own 32-band graphic EQ, as well as its own power amp, each monitor mix is, in effect, its own small PA system. While waiting for the first band to arrive, the crew has already set up a variety of mic stands. 3 12-channel subsnakes are laid out on the stage. One will be used for the downstage inputs, which are the vocal mics. The second and third will be used for the upstage inputs, which include the guitar amps, drum kit, bass, keyboard, and any other instruments. All 3 subsnakes are then connected to the master panel and clearly labeled. As we saw earlier, the 52-channel input snake is then run from the master panel to the front-of-house console. As soon as the band arrives, the crew begins miking up the drums. They know the sooner they get everything connected, the more time they'll have to solve any electrical problems that will pop up during the sound check. The kick drum mic is placed inside the drum head, about 6 inches away from the beater. These tom mics are Electro-Voice ND408s. Notice the capsule is swivel mounted and can be pointed down towards the point of impact on the tom head while remaining out of the way of the drummer. Each mic is labeled and marked. A combination of dynamic and condenser mics are used on the drums. Here, the engineer adjusts the overhead drum mics, a pair of Sennheiser ME40 condensers. Condenser mics are used for their high output and strong upper end and work well on the hi-hat and cymbals. Dynamic mics are used on the rest of the kit. a Beyer M88 for the kick, a Shure SM56 for the snare, Electro-Voice ND408s for the high and mid-tom, and a Sennheiser MD421 for the floor tom. For vocals, the engineer uses several Shure Beta 58s. With time becoming tight, the engineer starts the sound check, beginning with the kick drum, then the snare, then the hi-hat, then the toms. With each drum, the engineer will set the input gain, the compression, a noise gate, and EQ. The cymbals are last. To check the mic balances, the engineer has the drummer play the entire set. Next is the bass, which is run through a direct box from the back of the bass head into a subsnake.
It's hard to control it.
Next is the acoustic guitar. Because the acoustic guitar is using an internal bridge pickup, it's also connected to the subsnake using a direct box. Next is the keyboard. The first group is using only a single electric piano. It too will be connected to the subsnake through a direct box. While sound checking the remaining instruments, the engineer discovers a problem. The violin, which is using a wireless RF transmitter, is breaking up and sending a lot of noise in the signal. At the stage, the engineer decides to bypass the wireless entirely and run the output cable from the pickup on the violin into a direct box. Experienced sound engineers know there's always going to be a problem of some sort. That's why they always try to run a sound check before the performance begins. Now that the instruments and vocals are checked, the engineer sets up the monitor mix. Providing more instrument signal is as simple as turning up the aux send on the instrument channel. The band begins the first set, and the engineer works quickly to set the main mix levels. The engineer has pre-mixed the instrument channels down to these 8 VCA subgroups, making it easier to run the mix. So, from here to here, in just a few hours, another typical day in the life of a sound company.